Differential calculus. What is the meaning of differentiation? Differentiation means finding the derivative of a function. The derivative tells us the rate of change of a quantity, the slope of a curve at a point. This is what I mean by rate of change. This is the rate of change. For example, this is change in V to change in T. So we have a slope to be change in V onto change in T. So this concept, it is what we call differentiation. That is the first statement. He said the rate of change of a quantity. So the second one, he mentions about the slope. He also mentioned about the slope of, now he mentioned the slope of a curve at a point. For example, there is a curve like this, and you are to calculate the slope. And this curve is y is equal to s squared. So to get the slope of a curve, you just have to say that the y, change in y into change in x, if this is x-axis and this is y axis. So therefore we have change, you have 2x. So this is just the concept of differentiation. But we have some rules that will make this topic easier for you in solving some certain problem where you have to apply to it. So that is why you now have rules. So we have rule 1. In having a derivative of a constant, it let us to know that in rule 1, constant rule, the derivative of a constant is 0. Telling you that when you differentiate a constant is equal to 0, where c is any constant. Example, we have y is equal to 5. The differentiations of y to respect to x is equal to 0. Y is equal to 20. The derivative of y with respect to x is equal to 20. And also, y is equal to minus 7. The change in y to change in x is equal to 0. Why? A constant does not have change. So its rate of change is 0. How? What makes it not to have a change? Because the 5 is not with x. It is not a we don't. If it is 5x, it will be easy. The x will affect the 5, but the 5 is constant. It does not have x. So what makes this s meaningful to the s? We are differentiating with respect to x. That is the first rule. So when you are differentiating a constant value, it gives us 0. So we have another rule. We call it a power rule. This is the rule that gives us the formula for differentiation. If y is equal to s raised to power n, we have the y, the x is, n is in power, y s is base. You bring down the power to multiply the base, you subtract 1 from it. That is just the game. What are the steps? It obeys. It brings down the power, reduce the power by 1. So let's try to solve the example to have y is equal to s raised to power 5. We differentiate y with respect to x. And the formula lets us to know that you bring down the 5, you reduce it by 1, it gives us 5x raised to power 4. Another example, you have y is equal to 8, s raised to power 8. You divide the x, will give us 8 to multiply x. You reduce it by 1, it gives us 8x raised to power 7. So it still further explains that we have another meaningful example, which is y is equal to x. Y is equal to x, and you have to differentiate this. But there's some certainty you need to know about this. This y is equal to x can also be written as y is equal to s raised to power 1 because it's also raised to power 1. Therefore, changing y to respect to x, we have 1 to multiply x onto 1 minus 1. We have x raised to power 0, which is equal to 1 from the laws of indices, that anything raised to power 0 is equal to 1. Let's go to the rule 3. So we have another rule, constant multiple rule. If a constant multiplies a function, differentiate the function and keep the constant. You're able to see from the analysis that C f of s, the C comes out, but you differentiate the f of s with respect to x. So we have a question of this form to have y, for example, is 4 raised to power s, 4x raised to power 3. So therefore, we have the y, the x is equal to, the 4 will stay, but to multiply the 3x onto 3 minus 1, which is equal to 12x raised to power 2. So that is answered for that. So example 2, which have y is equal to 7x raised to power 6. The y, the x is equal to 7 to multiply, the 6 will come down, x onto 6 minus 1, which will give us 42x raised to power 5. So I can also have an example out of this example written here. Let's have y is equal to root x plus 1 over root x. Recall that it's also be written as x raised to power half plus 1 over x raised to power 1 over 2. So y is equal to x raised to power half plus x raised to power minus half, because there is a reciprocate. So we need to obey the laws of reciprocal. So therefore, now let's apply the rules to the game. So we have the y, the x is half, because this half will come down onto x. By the time you subtract half minus 1, it will give you minus half. Now, plus minus half onto minus half minus 1. So we have half onto s raised to power minus half, plus times minus will give you minus onto half onto s. So minus half minus 1, it will give you 1.5, which is minus 3 over 2. I just have to rush to do this. We are going to solve question relating to a tedious problem. So we are using this to explain as an elementary, so you'll be able to get the rules and the logic. So let's go to rule 4. So in the rule 4, it said the sum rule. Differentiate each terms separately, which let us to know that the f of s, the g of s with the s will give you, you differentiate f of s alone, you differentiate g of s alone. So let's try to do this example and let's see what it gives us. So we have y is equal to s raised to power 4 plus s raised to power 2. The y, the x is equal to, so we have a 4x 4 minus 1 plus 2x 2 minus 1, which is equal to 4x raised to power 3 plus 2s raised to power 1, which can also be written as 4s raised to power 3 plus 2x, because s raised to power 1 can also be written as x. So that is answered for this. So let's also solve this. Y is equal to s raised to power 8 plus x. The y, the x will give you 8x, 8 minus 1 plus 1 times s to the power 1 minus 1, which is equal to 8x raised to the power 7 plus 1 times s to the power 0 is equal to 8x raised to the power 7 plus 1 times 1, which is equal to 8s raised to the power 7 plus 1. So that is the answer for the second example. So that is how we solve. So let's go to the last rule for the elementary stage before we go to the function of functions and the other one. So we have different rules. Differentiate each term separately. It's the same thing about the sum rule. So the different rules is, so which we have y is equal to x raised to power 5 minus s raised to power 3 the y, the x, we have 5x, 5 minus 1, minus 3x, 3 minus 1, which is equal to 5s raised to the power 4 minus 3s squared. So that is the answer for that question. So the example 2, we have a y is equal to 3x raised to the power 4 plus 5x squared minus 7. The y, the x. So you obey the same rule, only that you're able to study one thing about here. There is a constant which you start from, it will be 0. So therefore, we have 3 times 4 s onto 4 minus 1 plus 5 times 2 onto s, 2 minus 1, minus 0. Let's just write it in that form to make it easy for the layman. So therefore, we now have the y, the s is now given us. So this is 12 onto x raised to the power 3 plus 5 times 2 give us 10 onto s raised to the power 1. So the final answer is 12x raised to the power 3 plus 10x. So if you stay to this channel, you're able to see the advanced topics of mathematics and engineering maths and the other one. So thanks for watching this video.